bring your exponent down and subtract 1 from your exponent, so squared. And then what does minus 6x become? There's a 1 up here. So 1 times negative 6 is?
6.
What kind of 6? Negative. And then 1 minus 1 is?
0.
And x to the 0 equals?
1.
1. So it's just negative 6 times 1 is negative 6. Okay? Now what do we do, guys?
You got the 3 from multiplying the the coefficient of 1, leading coefficient of 1 times
There's a
6,
1 here.
right?
Yep,
If
3
that was
times
2,
1.
it would have been 6.
Exactly.
Okay.
Good. So now we just plug in 2. I'm bored. What's 2 times 2?
4,
Times 3.
12,
Minus 6.
6.
I'm done. Easier than you thought? Yeah. Most of these are a don't overthink it kind of scenario.
I got both of these 6. I was just wondering,
Why? Because it's the same thing. It's their sneaky, weaky way of saying, oh, it's the same thing. Which, yeah. Okay, yeah.
On the exam, are we ever going to have to do it the long way, or is it always going to be the short way?
Never going to make you do it the long way. I may ask you what the long way is and what it means, but I'm never going to ask you to do it. But you need to know what it is. You need to recognize it when you see it. Okay. So that's number 17. Let's look at 29. 29. Is this 4x squared minus 1 over x in your textbook?
Yeah.
You asked for it, right? Okay. Okay. At x equals negative 1/2, write the equation of the tangent line to each curve at the indicated point. So it wants an equation of the tangent line, guys. It wants y equals mx plus b. It wants an equation of a line. Okay. So the y equals mx plus b for f of x equals 4x squared minus 1 over x at x equals negative 1/2. God, I'm mean. Look at how mean I am. Is it pretty? Mm-hmm. How do I make it pretty? How do I rewrite it? Well, 4x squared is definitely in the right format. But if I bring this up, this becomes negative x to the negative 1. You guys with me? Yeah, it's really nasty, isn't it? Great, what's the derivative? Negative 1 times negative 1 is 1. X to the negative 1 minus 1 is negative 2. Okay. So now I have the derivative. If I plug negative 1/2 into this, I will get out the slope. Where do I plug negative 1/2 to get the corresponding y value? So right now I have x. X is negative 1/2. So where do I go to get the y value? What do I do? That's right. Plug x into a function, get out a y. Plug x into a derivative, get out a slope. So we're going to plug x equals negative 1/2 into our original function. So I'm going to do that in blue. So f of negative 1/2 is 4 times negative 1/2 squared minus 1 over negative 1/2. Wow, that's beastie, isn't it? Well, it isn't so bad, because negative divided by negative is what? Positive. And this is just going to invert, so this is going to become plus 2 once we simplify it. Negative 1/2 times negative 1/2 is what? Negative 1/2, yeah, times negative 1/2 is positive 1/4. And what's 4 times 1/4? 1. Yeah.
Did you forget to put the exponent
Nope.
of your 8x squared?
Nope. Because I'm working with the original function.
Oh, you are?
Not
Okay.
the derivative.
Okay.
Yeah. Okay. So this becomes 1 plus 2 equals 3. So that's my y, 3. And I'm going to get my m from plugging negative 1/2 into the derivative, right? Let's do that over here. F prime of negative 1/2 equals 8 times negative 1/2 plus, there's a negative b for doing this, negative 1/2 quantity squared. How did I do that? How did I get this set up from this in red? How did I do that? If I take this back downtown, what does the sign become? Positive 2. And what stays behind on top? A 1. So now I'm just plugging in negative 1/2 for x, which is going to be a positive 1/4. And when I invert that, this is going to become 4. So what I get here is negative 4 plus, oh, that's nice. 4 equals 0. My slope is 0. So what's b by default? 3 equals 0 times negative 1/2 plus b. What does b equal? Yeah. 3 equals 0 times negative 1/2 plus b. b equals 3. So what's my y equals mx plus b?
Y equals 3.
Yep. Y equals 3. Good. Questions? No doubt it's a beast, but the hardest part here is the algebra, isn't it? Figuring out what to do with a negative x that's also a fraction, and you want to rip your hair out. I understand, you guys. We'll all be bald at the end of the semester. It's okay. No? No? Okay. I'll be bald. It just gets shorter and shorter and shorter. Are you flipping me off? No. I'm very sensitive to hand gestures. She's sitting here like this. I'm sorry. I'm just teasing you. It's okay. You can flip me off. I get it. I understand. Like, this is hard stuff. It's okay. It's cool. I'm immune, but I'm sensitive to hand gestures. So, like, I saw your hand move, and I'm like, oh, is it a...
No.
Nope. No. Okay. All right. I'm sorry. Totally good time. No, it's okay. It's fine. Yeah.
So why would you plug it into that one instead of the one down there? Like, I get how you got to that second equation, but why would you want to do that?
It depends on what I'm looking for. So if I want to look for y, I'm going to go to the original function to get y using my x. If I want slope, which is my m, which was the next thing I was looking for, I would plug x into the derivative of prime. So that's what I did here. That's not what I did here. That's what I did here.
Yeah, I know, but I'm saying, why would you not want to just put it into the original one we got?
Oh, right here?
No, so like these.
Right here?
Like, the derivative we already found.
Yes.
Yeah. Why would you want to convert the second, like the 1 over x squared?
Oh,
And the next one.
do you know what this is? I have no idea what that is. You can plug it into your calculator and figure it out. But if I move it back downtown and change the sign, it's a lot easier for me to do it in my head.
Okay.
Does that make sense?
Yeah.
So I just get comfortable with moving things uptown and downtown. Uptown to take derivatives, back downtown if it's negative, so that I can figure out the answer without unburying my calculator, because I'm lazy. And that's basically why. I hope that helps. Okay, so that was 29. Let's look at 33. Who asked for 33? Yes. So do you have x to the 4th minus 4x cubed plus 9 as your 33? Okay. Ruby. 33. F of x equals x to the 4th minus 4x cubed plus 9. Now what the hell am I supposed to do with this? Find the coordinates of points where the graph has horizontal tangents. Horizontal tangents is math speak for what?
Axis and middle.
A slope of 0. Okay? So it says find coordinates where slope is 0. And when I say coordinates, what does that consist of?
X and Y.
Yeah, x and y. So I'm looking for the x and the y. Groovy? So remember, we have a road map.
Do you have a handout that like explains all of those like wordings and stuff? Cause I looked in the 9.4 one and it wasn't there.
9.3. Sorry. It's in 9.3. It's all there. Yep. So find coordinates where the slope is 0. So what am I going to do? I'm working with slope, so I need the what? Derivative. Yeah. So let's just take the derivative of this real quick, which is what, guys? What happens to that constant by itself? You killed it, killer. Yay! I know, it's so violent. You killed it, killer. So now, we need a slope of 0. So slope is really just your derivative. So what are we going to set the derivative equal to? 0. Yes! 0 equals 4x cubed minus 12x squared. What can I factor out of both of those terms?
4.
A 4 and
Squared.
an x squared. All right. So if I yank 4x squared out of this, what's left over in this first term?
X minus 3.
X, and then this will be a minus 3 left over in that next term. How many of you understand that there are 2 solutions to this? Okay, why are there 2 solutions?
Depending on what is asked.
Yeah, so we want coordinates where the slope is 0, but here's the thing. There may be more than one place. For example, if you have a function that x to the 4th minus 4x cubed is 9. Let's just look at a cubic, for example. There's 2 places where the slope is 0, right here and right here. Those are 2 different coordinates, okay? So sometimes you're gonna end up with more than one term containing an x, and if that's the case, you have to set them both equal to 0 and solve. And the reason is, we have to make the statement true. If 4x squared equals 0, is this statement true? No matter what the value is, times 0 equals. So if this goes to 0, your statement is true. If x minus 3 goes to 0, is this statement true? Because anything times 0 equals 0. So we have to set any term containing x's equal to 0. So we can figure out all the values for x where the slope is 0. You guys with me? Okay. All right, so the next step here, it's okay, shout it out. Yeah. So x equals 0 here, and x equals 3 here. Okay. But am I done? Yeah? No?
Now you have to find the Y value.
Now I have to find my y values, Adam. Good.
For coordinates.
Because I'm looking for
Does it all
coordinates.
matter?
Oh, Ryan.
Damn it.
Yes,
Can you
Caitlin.
go over again how you got like the second, like the bottom, like one in red?
This one?
Yeah.
I just factored this. I figured out what they both had in common so that I could solve for my x's. So they both have x's in common. How many? 2. So I can yank an x squared out of both. And if I do, this first term is going to be left with an x. I can also pull a 4 out of both of them. So 4x squared coming out of the first one leaves an x. 4x squared coming out of the second one leaves a negative 3. Okay? So where do I go to get my corresponding y's?
Back to the original.
Yeah, this is the road map. So the function at 0 equals what? We can do that. 9.
Right.
So my actual answer is 0, 9 for that first set. And what's my function at 3? Well, that's going to involve a little work. 3 to the 4th minus 4 times 3 cubed plus 9. 3 times 3 is 9 times 3 is 27 times 3 is 81.
Yeah.
Yeah, 81 minus
81.
27 times 4 is
81.
108. 108, right? This will be 108, I think.
Yeah, right.
81 minus 108. Oh, for heaven's sake. Is 27. Negative. Plus 9 is
36.
negative 27 plus 9. I'm trying to do this in my brain, it's not working. Negative 27 plus 9, thank you. Is negative 18. So it's going to be 3 comma negative 18. Oh, sorry, these should be parenthesized and then boxed. No, I don't know, somebody can check me. Was it right? Oh, good.
If you put 0 in for x, oh, did you plug 0 in for x all the way up to the original function?
Yeah, absolutely. Absolutely. And you can tell that because I'm giving you that sort of hint right here when I say f of 0. I'm plugging in 0 for x on f of x. If I were doing f prime of 0, I would be finding the slope when the x is 0. So it's all about how I choose to write this as to where I go. That's fun. Okay. So let's tackle that last problem real quick. So I have a feeling you guys are gonna like today. I really do. I really do. I swear to you guys. Not messing with you. Cost and average cost. So how many of you have read The Basics of Business in the context of this class?
I was thinking about it.
You were thinking about it, right? Thinking hard? You have?
You maybe do it on Thursday.
I did. And was it useful?
Yeah, everything made a lot more sense because it just plugs into all of it,
Yeah.
so it doesn't look like hieroglyphics.
Yeah. I highly recommend reading my handouts, guys. Not making you read the book. Trust me, it's worse. But you do want to read my handouts. You really do. Okay, so number whatever it is. Cost and average cost. Okay. We're given a cost function, C of x equals 4,000 plus 55x plus 0.1x squared. And then they tell you how to build an average cost function out of that. Average cost, C bar of x, equals cost divided by x. So how am I going to build average cost out of this? Anybody? I take a cost function and I divide it by? All right. So in this case, it's going to be 4,000 plus 55x plus 0.1x squared divided by x. That's ugly, isn't it? What if I split it up? Can I do that?
Thank you.
Heck yeah. Can I simplify that? Yeah. So my average cost function is 4,000 x to the negative 1. I'm going to go ahead and make it pretty, guys, because we know we're going to be taking derivatives. 55x over x becomes 55. 0.1x squared divided by x becomes 0.1x. So now I have my average cost function, which is not the derivative of cost. It's not the same thing, guys. Yeah?
I'm not really sure that fractions.
What do you mean?
So, give it a negative 1.
So I haven't taken a derivative yet. First of all, I have not. Yeah, this is not a derivative. This is a new function based upon the function we were given. Okay? So when I drag this up, what's my exponent going to change to? -1. That's all I did. I just brought it up down and changed the sign. Does that make sense?
Yeah.
Awesome. Okay, so now what does it ask us to do with that nasty
So
little?
when you bring an x to the top, you just make it negative. You don't like take one away or anything like that.
No. You make the exponent negative. Yeah.
That's
The,
it.
the x itself stays whatever sign it was. Okay. All right. Find the instantaneous rate of change of average cost with respect to the number of units produced at any level of production. So translated, take the derivative, and whatever derivative you get is good for the slopes at all x, at all levels of production. X is always production, guys. Usually. Occasionally it's also time, but we'll get to that. These are tight. So we want the derivative. It's pretty. What's our derivative? X is the what? -2. What happens to 55? Killed it, killer. What about 0.1x? What does that become? And you're done. That's your derivative, good for all x. Good for all levels of production. Okay. Part B, find the level of production at which this rate of change equals 0. Rate of change is another way of saying derivative, where this derivative equals 0. So we're setting the slope equal to 0 and solving for x. And at this point, it's just an exercise in algebra, isn't it, guys? But you're scared by that -2, right? It's cool. You can be scared by the -2. So, what am I going to do to this? I'm going to bring the x squared back downtown. I'm also going to bring the 0.1 over here. I'm just going to move it over. So -0.1 equals -4,000 over x squared. Is everyone okay with what I've done there? Let you guys stare at it for a second. This is in your way, isn't it? Is that better? Now what? What do I multiply both sides by to get it all on one level? So -0.1 x squared equals -4,000. Now how do I isolate the x squared? Divide both sides by? So x squared is going to be 40,000. Right? Okay. If I take the square root, I get 200. Plus or minus 200, which one do we keep? Remember, x is production. Can we make negative things? That's right. So we keep the positive one. That's the only one that makes sense in the real world, right?
What's it going for?
Positive. Positive 200. I erase the negative because we don't do negative production. It's impossible. Can't make negative things. Okay.
Where were you getting a negative though if you were taking the square root of a positive?
Well, what's the square root of 4? It's also -2. So it's -2 quantity squared. 4. Right. So it's contextual. In these cases, when we're working with production, we don't need negative numbers.
You have to put the positive in front of it?
No. I just erased the negative because I had plus or minus 200 in
So
front
you
of it.
could just say x equals 200?
Yeah.
Okay.
Yeah. Okay.
And so say that square root did come out a negative, like is a totally different problem. It plus or minus, like whatever that was,
Mhm.
and then you would just make it positive.
You would make it positive because of the context.
Yeah.
In application problems, we can't have negative production.
Right.
So we would discard that negative answer,
Okay.
and we'd be set with the positive one. All right, so that's part B. Part C, at the value found in part B, find the instantaneous rate of change of cost and find the average cost. What do you notice? So we would take this 200 and find the instantaneous rate of change of cost and plug it in. And it wanted us also to find the average cost, so we would plug 200 into this as well. And that's all it wants you to do, is plug them in. Creepy? What do you guys feel about these? I think 99% of it is just understanding what the hell it wants you to do. The math itself is not the hard part. Yeah,
In C, they would be equal, right?
yeah, they would be.
Every time.
Yeah. Yeah. They should be every time. And the reason is, guys, cost looks like this. And if you guys have read the basics of business in the context of this class, here's dollars, here's production. Cost looks like this. Some version of, it starts at some X or some dollar amount because this represents your fixed cost. But average cost looks like this. Here's production, and here's dollars. Average cost looks like this. Okay? So at some X value, you're gonna bottom out. So in this case, it was 200 units of production, causes us to minimize our average cost per unit. So basically, we're trying to optimize our production here. We spend less per unit at 200 units than we do in any other place along this function. Does that make sense? Okay, so it's really hard to minimize cost. Visually, you can't, right? There's nowhere it bottoms out. Obviously, your minimum cost is when you build nothing. That makes sense, doesn't it? If you build nothing, you're gonna minimize your costs. But you can minimize your average cost. So that's why we have cost and average cost as two functions we analyze together in tandem. Because one gives you your overall cost and the other one allows you to optimize for cost per unit. Okay? All right. You guys good? Ready to tackle 9.5?
Yeah, sure.
La, la, la. You guys ever get like really awful news and you just take forever to process it? God, I'm sorry. What's that one?
Are we gonna copy this with you Wednesday? This is on Monday, right?
No,
No.
it's on the 23rd. You've got a ways to go. Or not the 23rd, that's the Tuesday, Thursday group. You guys get it on the, yeah, the 23rd. Yep.
Which is not this Monday, but next Monday, right?
Yep. No, it's not even next Monday.
No, it's not.
Yeah, it's 2 Mondays away. Because this Monday's today.
Yeah.
I know, okay, I know this up.
No, it'll be the week after that. Like, I'm so confused.
When it says on the schedule, homework over T1, does that mean you're gonna like pass out like problems for us to answer that?
It means that the homework that I assigned for the chapters that are due for the test, let me say that again. It means that the homework that I've assigned that you're going to be tested over is due at the test. That's what it means. So all the chapter 9 stuff that's going into test 1 will be due at test 1.
Right, but it says that on 9/16. It says it like a couple of days before.
Oh, that's the handout. That's a checklist that I give you to prepare for review. Yeah.
I think I just thought that was.
That's okay. Nah, it's just a checklist that I give you. This is what you need to know for the test 1 stuffs.
Do you give out like any extra practice problems or
Nope.
anything like that?
Nope. Some people love that, some people hate it.
I've got a question.
I have an answer. I'll tell you why in just actually, let me finish her thing and then I'll tell you your thing. I don't assign practice problems for several reasons. The biggest of which, if I give you guys practice problems that are exactly like the test, that is A, insulting to your intelligence, and B, you learn nothing. Because you could just put those on your cheat sheet and change the numbers, right? That teaches you nothing, okay? If they're too different, you'll feel cheated, okay? Won't you? This looks nothing like the review sheet. What the hell did she do to us? That's unfair. So instead, I give you a checklist of things you should know, and if you want me to work some problems on the board, I will, but there's no guarantee they're gonna look like what's on the test. So I give it a week out, a week early, so you can take it home, look at it, and come back with questions. That's why I do what I do. Groovy. Yes, Ryan.
What was the terrible news?
Oh, it's nothing. I was just filling in the erasure on the board. Not important.
Well, but like, I don't know. Sometimes I feel that way.
Yeah, it
Like,
sucks,
the
doesn't it?
process, like,
It takes a while to
Yeah.
process.
you're
It
like,
really does.
oh wait, and then then it just like hits you like a week later.
So my dad last week, he's like, I have cancer, and I'm like, okay. And he's like, it's not okay, and I'm like, I know, I just said okay because I'm processing. Because then okay, ... not okay, that's cool, Dad. Yeah, that's what I was talking about.
I'm sorry.
No, it's fine.
What kind?
Did it to himself.
What kind?
Prostate.
Gotcha.
Yeah, just get your bits checked, guys, when you hit a certain age. Just do. Just do. It's cool. Won't hurt you much. Because biopsies, they hurt. So that's what happened. He went in for a biopsy 10 years ago and it hurt, so he didn't go back. And I'm like, my dad, like I said, he did it to himself. The process. 9.5. Product and quotient. Oh, that air feels so good. It's muggy today. It's because of the fog this morning, isn't it? Like, it never went away, did it? Did you guys see fog this morning, or were you sleeping through it? You saw it? Okay, good. I'm not alone, yay. All right, product and quotient. Which one's which?
Product is multiplication, quotient is division.
How do you remember that?
You're a product of your parents.
Yes,
They multiply.
yes.
Can you speak up?
Say it for the class, Memo.
Well, that was your idea.
That's right.
Yeah, you're a product of your parents. Like, they multiplied to make you.
Yeah. So product is multiplication. Congratulations. You'll never be able to look at it the same way again. Okay, so product is multiplication. We have some function times some function. And a quotient, we have some function divided by some function. Okay? So these are our basic functions broken up into sub-functions. And you will learn to recognize these, namely, if there's parentheses and divisors, you're gonna see it. Pretty easy to see. So what's the derivative of those? Let's start with the product rule. So if f of x is u times v, f prime of x is gonna be the following. U prime v plus u v prime. So before we get to the quotient, let's do this one. La, 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 la. Who wants to FOIL that before they take the derivative? Raise your hand if you feel like experiencing pain today. I don't. Instead, I'm going to use the product rule. So I'm going to define my bits. I'm going to take the derivative of each bit, and then I'm going to plug them into the formula. So what's my u? The first bit. And then what's my v? The second bit, right? So then what's u prime? 14 killed the killer. What's V prime? 7. You're done. Now all I have to do is fill and chill, guys. You have your U prime, you have your V, you have your U prime, and you have your U prime and your U, you have your V prime and your V. You have all the bits. Just fill it in. So the derivative is
Are you saying we never have to factor again?
no, but I'm saying for these, please for the Lord, don't make it harder on yourself than you have to. I'll talk about what the book does and what you guys are going to do and how you're going to marry the two up in just a second. So y prime here is u prime times v plus u so squeaky times v prime.
You forgot an X on the 26.
I sure did.
Well, that's just my, yeah.
Pays to catch my mistakes. God, that's so nice. I barely had to work at all. How do you feel? After you get it written down, you can stare at it for a second. Just stare at it. That wasn't so bad.
Y
Yeah.
prime right there is just f of prime of x.
Yeah, it's just another way of saying it. All right, guys. What was the hardest part?
Is that it?
That's it.
Oh, I was gonna say.
You're done. You're done. Okay. You're done. Okay, I can't do it on this board. I'm just too sticky. Okay.
So all this is finding the prime, like
The derivative
of the
A product. Yeah,
Okay.
that's it.
So how exactly would that look in the actual problem?
Just like that.
Oh, find the derivative of the product.
Yeah. Just like that. Or find the derivative of the function, and you're given a product, and you decide, okay,
Oh,
I'm going to
and
define my bits
that's-
and take the derivative of the bits and then plug them into the formula. So my formula was u prime times v plus u times v prime. I just filled in the blanks, guys. That's all I did. Damn, that was easy. Oh yeah. But for now, we keep it easy. I work you to the complications, guys. I work you up to them. I'm not going to throw you in the deep end and start screaming hysterically, look at you drowning. No, I don't do that. You come to me if you get stuck. That's my jam. Groovy? One of my colleagues asked me the other day, are you always this happy? Pretty much, except when I'm not. Let's look at quotients. You guessed it, it's gonna be a quotient. Here are the bits. U prime times v minus u times v prime divided by v squared. So once again, all we have to do is find the derivative of the top and the derivative of the bottom and shove them in where they go. And you're done. Let's look at one. Actually, I have notes on this. I should probably look at those once in a while. Make sure I'm doing everything that you guys need to see before I send you on your merry ways. Ooh, I like the look of that one. You guys are like sitting there waiting for the other shoe to drop, aren't you? How many of you don't know what that means? It's okay. All right. It's so flippin' hot in here. Oh my God. I'm moist. What's my U? This is Stuff on top. What's my V? Stuff on the bottom. What's my U prime?
12 squared plus 6, 6.
Yup. What's my V prime? We're done. I mean, we're not quite done. We have to fill in the blanks, but we're done, right? F prime of X, squeak, squeak, is U prime times V minus U times V prime all over V squared. So here are my labeled parts. U prime V minus U V prime V squared. That was easy. You guys like this, right? This isn't so bad. Yeah.
Are those formulas gonna be in the exam or?
Nope.
Cheat sheet.
They will be on your cheat sheet. Yeah, they will.
Yeah.
Along with a small example of each, probably. How big is your cheat sheet?
Note card, right?
No,
Oh, whole page.
a whole page. 1 or 2-sided. Don't get greedy. You get 2 on the final. Just 1. Yeah. I don't care how small you write, but it has to be handwritten. Must be handwritten, guys. No shrinkage. That doesn't teach you anything. But physically writing it down, because I'm an old-fashioned gal, forces you to do a review. So just by virtue of writing it down, you're going to learn something, or you'll remind yourself of stuffs. Ruby?
Are you gonna have us like simplify long equations down?
No, I'm not. But here's a trick. Well, here's the catch. It's not the trick. I'll teach you the trick in a second. The catch is the back of the book has these simplified. So your answers are going to look nothing like their answers. So how the hell do you check your work?
Just have faith.
Uh-uh.
Just faith.
Carefully.
Carefully. No. Why go through the math? Guys, we don't just stop with derivatives. In the real world, we're analyzing a point. We're going to plug in a number, right? So we don't care what the derivative is. We do it so that we can analyze points on a chart, okay? So pick a number, 1, that's cool. Plug 1 into yours and plug 1 into theirs, and if you get the same answer out of both, chances are pretty flippin' good you did it right. It's just in a different form. You guys with me? Okay. Do you want to see why I want you to do that?
Sure.
Why is that easier than just simplifying it?
Here's why. I'll show you how hard it is to simplify one of these suckers. Well, I have to FOIL this first. 12x to the 4th plus, what is that, 60? 60x squared plus 6x cubed plus 30x. So that's that. Minus, and I have to hold on to the minus sign because I need to distribute before I distribute the minus sign. 8x to the 4th plus 6x cubed, all divided by, I'm going to FOIL that out. Let's see, x to the 4th plus 10x squared plus 25.
X squared. You're on the
Oh, it should be
denominator.
x to the 4th. How many of you got that? What's your name?
Tristan.
Tristan and
Tyler?
Tyler. Anyone else? What's your name? Spell it. Chandelier. Oh, yes, okay, chandelier. And A-R or E-R?
ER.
E-R. Tyler. Tristan.
You seriously factored that in record time.
Uh-huh. Is it gonna take you that long?
It would probably take me longer.
Longer, right, but plugging a number in, especially if it's an easy number like 1, you'll be able to add it together in no time. I'm sorry, chandelier. Did I get that right?
You missed one.
I'm sorry. Hang on, don't tell me. Starts with a K, right? No, what is it? H. Haley. Haley. Congratulations, you guys. That's 1 point on your final grade. You can get up to 5 total before you like back off and let other people have a chance.
How many points are in class?
What?
How many points are in class?
I
How
don't
many
know.
people have a-
It's a point on your final grade. So if you had an 89, it kicks you to a 90.
Okay. So
I don't
percentage
know.
point.
It's, yeah. Yeah.
That's easy to me. Okay.
Yeah.
Gotcha.
Okay, so now I have to distribute this and collect like terms. Seriously, don't do that. Just plug in a 1 to yours up here, which is easy. What's 12 plus 6? 18 times 1 plus 5 is 6, minus 4 plus 3 is 7 times 2 over 2, or 1 plus 5 is 6 times 6 is 36. You can do this a lot faster, guys. Right? So checking your work by plugging a number in, so much faster than doing this. So much faster. I'm not even done, I'm over it. Okay. So, what do you guys think? Solid? Is that the you speak for that's awesome?
Easy peasy.
Solid? Tight? You guys used to say that like 4 years ago?
Yeah, she was tight. I was way more than 4 years ago.
How long ago was that?
I don't know.
I'm old, help me out. I'm old and feeble. My memory is not what it used to be. Help me out.
Is it not cool to use that anymore?
No, you can still use it.
No, seriously, in my day, it was rad. It was radical. It was awesome, heavy,
My favorite term from my dad's era was bitchin'.
bitchin'. Yeah, that's my era. Christ, I'm old. Okay. If you were surfer culture, it's tubular.
I say we bring that back.
Yeah, go back to that. Good times. You guys want to see another? I mean, like, they're not so bad.
We do one with a square root.
You
That's it?
sucker
That's
for
it, done?
punishment.
We're done with notes, so exactly.
No, we'll do some more.
Like some practice problems. right?
Yeah, we'll do a few more practice problems, then I'll give you guys your handout and you'll work your handout. Right? You're like, what?
Oh, that's what.
Samuel,
I'm good.
you're good?
Yeah.
Feeling frisky? You guys are doing calculus in your head, you guys, seriously. Give yourselves a break, pat yourselves on the back.
This is actually a piece of cake for me, so.
Yeah, that's great. No, seriously, I'm excited. That's good. So Memo asked for a square root, so you have him to thank for this. That's just your input instead of X. Now you're working in T. Yep. So this might be sales as a function of time, right? Who knows? Product or quotient? Is it pretty?
Nope.
Can you make it pretty?
Yeah.
What do you need to change?
So square.
That first term on the numerator, it becomes what? 2 to what? 2 to the 3/4. Okay. So what's my u prime gonna be? I'll get you started. Brandon, you have it? Haley, do you have it? What kind of 1/4? Right? Why is it negative 2? So when you subtract 1 from this, 3 minus 4
Yeah, right.
gives
It's
you
gonna
negative
make
1. Good. What's v prime?
green tea square. 2 minus 1.
What's my derivative, guys? so pretty. S prime of t equals, I'll like move so that you guys can all see it. U prime, things I do for love. -1/4. That's my u prime times v, which is, oh good God, t cubed minus u, which is 4/3 t cubed minus 4 times v prime, oh good God, 3t squared minus 4t minus 1, all over v prime, or v squared, t cubed minus 2t squared minus t minus 1 squared, done.
Is that the format we're always getting to, or
Yep.
those two over there?
Yep.
Okay.
Always, 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 always. So you define your u part and you define your v part, and then you take the derivative of each part, and then you plug them into the formula and you're done. Isn't that awesome? Yeah. I mean, the mess is in the details, but the process ain't that bad.
The hardest part is just writing it down.
Yeah, it takes longer to write it down than it does to take the derivatives, guys. Yeah. It's kind of awesome.
So would you use the derivative to find slope, or
Oh yeah, it's a derivative just like any other derivative. So it asks you, if it asks you to evaluate the slope at say x equals 2 or t equals 2 in this case, you would plug 2 in for t and see what the slope is that you get out. It's the same thing over and over and over again. It's a great question because you guys are gonna find out that you're gonna get really sick of doing the same damn thing over and over and over and over and over again. There's a reason we do that. We do that so that you can get familiar with the processes, okay? Let's do a application problem because you guys seem to struggle with those. So let's take a look at one. Ooh, goody! Such fun.
Do you mind if we use the t to 3/4 instead of the 4 square root?
Ah, not at all. They're still correct, right?
Yep.
Yep. It's all good. You are Tristan.
Yep.
Yeah. Tristan. Oh, I'm sorry. Who missed it? I'm sorry.
Just what was the V?
The V, so here's U prime, here's V,
Prime.
here's U, and here's V prime.
Okay, got it.
Yeah. Awesome.
So I just have to copy it down so that I can,
No
like,
problem.
like solve for it, but.
Absolutely.
Maybe.
Yeah.
Remember the B5 nominator minus the denominator, like nominator minus denominator all over. So 3 minus 4 is -1 and your denominator. Because this is, remember, u prime, so I'll show you that much first. This is your u times your v, which is just that. I'll get out of you guys' way in just a second.
you're selling something, who cares what it is, you're selling it. And you have to build a revenue function. Well, I did it for you. But I want you guys to understand where this function came from. Okay, so that's why I wrote this on the board. So just give me a thumb when you're done writing it. I'm gonna wait till everyone's done writing so we can talk about it. So if you're done, take a rest, shake out your hand. I know I will. Because if you've been writing all day, you're kind of over it like me, right? Yeah. Ooh, that one feels good too. Ooh, ooh. Okay. So the first thing, you guys all still writing? A couple of you still writing? Okay. Give you guys a second longer.
In a regular calc, would they make them simplify that all?
Yeah, they'd make them simplified. They would also make them synthesize this. They wouldn't give them the function. They'd be like, you build it.
Fun.
Yay, business calc.
Yay, business calc. Woo! But guess what, you guys? When you go into your business classes, they're going to ask you to synthesize crap like this all the time. So you're not done. You're just learning how to do it so that you can do it later.
I know it's like not mandatory for this class, but since we have extra time, would you like show us how we synthesize?
That's exactly what I'm waiting to do until everyone's got it written down so they can give me their full and undivided. All right, now Maria done? Okay, just waiting for pens. Okay, so you sell 200 units per month at $400 per unit. Well, that's freaking awesome. Does anybody know what revenue is based on? How do we make revenue? Yeah.
Revenue minus cost.
That's profit would be revenue minus cost. That would be profit. So yeah, you're kind of there. But revenue is actually based on two things.
Cost in units.
Not cost, price. Careful. Cost in our context is how much it costs to make the thing, not how much it costs to the consumer. So it's price times the quantity sold. For example, if you sell 200 $2 toothbrushes, what was your revenue? $400. You took the price of each one, $2, times the quantity sold, 200, gives you $400 in revenue, right? So revenue is price times quantity. Okay. So we have a baseline. We have a quantity of 200 at a price of 400. And now we have to modify that. So at this point, I have revenue at 200 is literally, price, let me put the price in there, 400 times 200, okay? Okay? Okay. But we have to modify this because this is only good for 200 units sold, right? So now we have to modify our price, P. This is our little price, and our quantity, X. Okay? So if you sell, or if you reduce your price $1, you'll sell one more unit. So now we're going to modify this 200 times 400 and saying if we go down one in price, we'll go up one in quantity. You guys with me? Okay, so that's where the modification comes in. So this is my revenue. So this is how I synthesized it. Does it make sense? Okay, so this is my revenue. And here's the price part of my revenue, and here's the quantity part of my revenue. All right, so I literally have a part of it that's price and a part of it that's quantity. So far, so good. Now, X is the units beyond 200 units sold. So if X is 5, how many units did I actually sell? 205, not 5. You guys with me? So this matters. If X represents units beyond 200 units sold. Always, always, always go back and check your units, okay? Because that's gonna matter. So find marginal revenue for 250 units sold. What am I gonna plug in for X? 50. So I'm actually gonna do marginal revenue when X is 50. You guys with me? This is what I'm looking to do. All right.
Where'd you get the 50?
Ah.
You just decided?
Nah, because I asked you to find marginal revenue when 250 units are sold, and X is going to be the units beyond 200. So the units beyond 200 for 250 is 50 units.
I think I'm also confused where like 200, like you have 200 in for X over there, like.
Right, this was the basic setup where I have some price times some quantity, then I modified it to create my real function. Okay? And then I recognize this has to happen, so if I'm looking for 250 units sold, I'm not going to plug in 250 for X. I'm going to plug in 50 because it's the number beyond 200. Yes?
Wouldn't the price and quantity be the opposite? So
Oh
this is
God, yes it would be. What's your name?
Marco.
Marco.
Well done, Marco.
It's
Oh.
like 2 points right there.
Not.
You see it as DEMARCO on the.
Yeah, but what do you want to be called?
Either one, I don't know.
What did you tell me at the beginning?
Marco.
Okay, Marco it is. Okay, so this is 200, this is quantity. Thank you, Marco. And this is price. Okay, price times quantity, quantity times price. 4 times 3 equals 3 times 4, so I'm just reversing which one came first. Okay, so you can do this one of two ways. You can FOIL it out and then take the derivative, or you can use the product rule and take the derivative. Clearly, since we're in the product and quotient rule, it might be smart to do that. So let's play with it. So what's my U? Yeah, what's my V? Yeah, so marginal revenue, which is the derivative of revenue, is U prime, 1, times V, plus U, 200 plus X, times V prime, -1. That's a crappy R. It doesn't even look like an R. It looks like an alien. Let's write that again. That's better. So much nicer.
I'm sorry, can you explain that?
Yeah. So all I did was I defined my U in my function and my V. So what's U prime going to be? What's the derivative of 200 plus X, guys? 1. And what's the derivative of 400 minus X? -1. So these are my bits. Here's my U. Here's my V. Here's the formula, U prime V plus U V prime.
Maybe I'm missing something that's pretty obvious, but like why is 200 plus X 1?
Okay, what's the derivative of 200, Caitlin? It's a constant by itself, right? What happens to constants by themselves when you go through?
Then
It dies.
disappears. Yeah.
Right. And then what's the derivative of 1x?
Okay.
Good.
Sorry.
It's okay. That's what I'm here for. So now what do I plug into my marginal revenue? 50. Yeah, 50. So my marginal revenue at 50 is going to be 400 minus 50 plus 200 plus 50 times -1. That's what, 3 What's 200 plus 50?
250.
250 times negative 1 is negative 250 equals $100. So now let's interpret that. The 251st units sold should bring in about $100. I'll let you guys stare at that for a second.
So you were saying that, like, when he like switched, when he mentioned that it's like quantity and price and it's flip-flopped, that it could also, like, 400 minus X could also be in front of, like,
Yeah.
times 200 plus.
Oh,
X.
yeah.
Does that change, like, what
No.
your B and your U would be?
No, because A plus B is the same as B plus A. So the nature of algebra is that if you're adding two things, 3 plus 4 is the same as 4 plus 3. 3 times 4 is the same as 4 times 3. But 3 minus 4 is not the same as 4 minus 3.
So it's
So
not gonna matter.
it matters when you're doing quotients because of this minus sign. It doesn't matter when you're doing products because they're both adding. So it doesn't matter which chunk comes first, as long as you're multiplying the right chunk to the right chunk. Okay? So is everyone cool with why it says 251st?
No.
You had your hand up.
Oh, no.
You got it?
It's
Groovy. Okay. Who said no? Okay. Adam. Where did I get 250 from, first of all?
From the 50 units.
From the statement of what I want you to find,
Yes.
right? And the 50 comes from the X value, which is over and above 200 units sold. But remember, slopes are rise over run. So my run is over 1 unit in X. So we're going from 250 to 251, okay? And my rise in expected revenue is gonna be $100. Groovy? Okay, all right, good guys. Size on hands.
I was gonna say like what if it was only 10 units over?
If it was 10 units over, I don't, what do you mean 10
Like
units
if
over?
it was-
Oh, like 210 units sold? Then it would have a different slope. Yeah, you would plug in X equals 10. Awesome.
Like on the test, if we didn't write the 251st units sold, and we just put equal to 100, you can take points off or something.
Yeah. Oh, I counted them wrong. I did count them wrong. You'll have an extra, that's fine. There'll be an extra. No, if I ask you to do an application problem, I expect you to be able to answer it. And part of the answer is the interpretation. Tell me what your number means. The number without what its context is meaningless. 30? 2, 4, 6, 7. So we still just have a couple of minutes. I want you guys to give these a try. Homework? Yeah. I'm like, yes, there is. No, I'll put it down. 9.5. 1 through 19 odd. Cost benefit. Revenue times 2. What I mean is there are 2 odd revenue problems in this section. Please do both of them. So you're gonna have 1, 2, 3, 4 application problems. Candidate recognition. again, resist the urge to stop when you hit the application problems. Because they are the most important part of what we do here. Namely because when you leave this class and you go back into the business world of your other classes, they're gonna expect you to know this stuff. Yes. Let's see what you do. Yeah, when it's doing quotients, you can't do that because that minus.
Let's wear pants and a sweater today.
Oh, why I wear a sweater?
It's hot.
Stupid. I'm like dying.
It's hot and it's humid. It wouldn't be that bad if it was like brown and dry.
Hi. Yes. And you get another point. Oh, you didn't say anything. Dad, now we have to remind me, otherwise. No, you'll get your point. You'll get your point. So now you're sitting at what, 2 points? Congratulations. So, yes. Yeah, that way everyone's handouts get corrected. That's okay. Thanks, Tyler. I'm glad you got it. Yeah, I'm gonna text me, so I'm glad you did. I will respond ASAP always.
Thank you.
Got some extras for you.
Yay!